Hi, my name is Sergio Rodrigo and this is Codurance screencast. Today I want to show you how to implement the Boolean Kata in Kotlin using some of the features that the language provides. We are going to start with the first test, which is when the user doesn't knock any pins. To make this pass, we can return 0. The next test could be when we knock only one pin. To make this pass, we could say if all rolls equals 1, then return 1. In Kotlin, there is another way to write this. We could replace the call to the equals method with the equals operator. And what Kotlin is going to do is it's going to translate the equals operator with a call to the equals method. So it should be the same. And it passes. Another test we could write is 2. And we could do something similar. If all rows equals 2, return 2. Now we could create a test which is a bit more complicated and involves 2 rows. So this is going to force us to write an algorithm. To make this pass for now, I'm going to write the simplest solution. And for now, I think we can try to refactor this and create an algorithm. So you could say, for each row in the list, if we calculate the score and accumulate it, the result should be the same as previously. So we can create a function that is going to calculate the score for one row. And it's going to return an integer. To make this, we need to convert the roll into a string and then calculate the int value. So if we say convert it into array, then to a string, and then to an integer, the test should pass. Another thing we can do is, because the body of this method, or this function, is only one line, we could convert it into expression body. And we could also get rid of the return value, because Kotlin is going to infer it. And the test passes. So I believe we are done with pins for now. One thing that we could do is, we could rewrite the name of this method using quotes. And this allows us to use other symbols, such as white spaces, or in case we are using money, we could use dollars, or pounds, or some other symbols. And this is very nice because we could write better specifications for our tests. These tests should still work. We could go now for a different case, which is when we throw the ball and we fail. And we are going to represent this using a dash. To make this pass, we need to handle this case, because for the moment we are only handling pins. So in Kotlin we could use pattern matching, which is similar to a switch case, but much more powerful. So we could rewrite this and say, if roll is in a range from 1 to 9, then do the same thing as previously. And otherwise, return 0. The next test we could try is, we could try to mix pins and misses. And it works. Before we go for a new case, we could try to improve our code. We could try to write the same algorithm using functional programming. So Kotlin provides functions on sequences, such as filter, or map, or flat map. In our case, we want to use fold, which is going to take an initial value and an operation, and it's going to apply the operation to all the elements of the list. So in our case, the best case is 0, as previously. And then we can pass a higher order function as a lambda, which is going to take the current score and the roll. And we need to do the same. We need to add the score of the roll to the previous score. And it passes. We can go now for a new test case, which is spares. Spares are a special case. When we knock, let's say, 3 pins, and then we knock the remaining 7 of the next roll within the same frame, that's called a spare. And its value is 10 plus the value of the next roll, which in this case is 0. So the value of the spare is going to be 10. So we need to handle this case in the pattern matching. We can add a branch. And this still fails. And the reason for this is it's expecting 10, but it's returning 13. This happens because we are saying the spare is 10, but we are adding previously the value of the pins, so it's counting twice. So we need to adjust that. And for this we're going to need to know what's the position of the roll in the list. For this we can use the simfold function with an index. And Kotlin is going to keep track for us of the index of the current roll. This is going to return an integer. In case the roll is a spare, what we want to do is we want to subtract the value of the previous roll. For this, we could use an extension function, which is a way to create a function on an existing class without modifying the internals. So in this case, we're going to create one on top of the string class. This also allows us to access to internals of the class. So in this case, we can access to a list of characters. And in case we find an invalid index, we can return something that we don't compute, like a miss. As we can see, we've got some duplication. The spare is duplicated, so we can extract this into a constant. In Kotlin, we can declare constants using the const keyword. And we could do the same with a miss. The next test we need to add is when the spare has a bonus. So in this case, the value of the first spare is going to be 17, and so on. So we could say, if the row is a spare, we need to add the value of the next row. So we could do something similar as we do on a spare div. We could create a new extension function on the string class. We are done with the spares for now, and we can introduce a new special case, which is the strikes. Strike is represented by an X, and the value is 10. To make this test pass, we could do something similar as we did for spares. We create a new branch. And a new constant. But in Kotlin, we don't need to use a second branch. because spares and strikes return the same value, 10, you can reuse the same branch and add the strikes to the spares. Another test we need to add is the bonus of a strike. In this case, the bonus is going to be the next two rolls. So 10 plus 7, 17, plus the next frame, 24. So we need to add the bonus for a strike. Before we do this, we could convert this if-else into a when. So now we are in a much better position to use pattern matching. And this passes. Another case we need to add is when we mix both spares and strikes. And this fails because when we calculate the bonus for this strike, we are saying that it's the value of the next two rolls, but we are also adding the bonus of the spare, so we need to fix that. And we can refactor this a little bit, because we have some duplication. The last thing we need to do is to calculate the score for the last frame. This frame is a bit special, because it contains 3 rolls, but if we score a spare or a strike, we don't need to count the bonuses. An example of this is this test. The last frame contains 2 strikes and 6 pins, so in this case, none of the strikes is going to have any bonuses. And this test fails. So to make it pass, we could say, if it's the last frame, then we return 0. To solve this, we need to take into account that the number of normal frames is 9, and each one contains 2 rows. When we score a strike, we only throw the ball once in that frame. So we need to convert that frame into 2 rows. To map this, we could use the map function. So if the roll is a strike, it's going to count as 2. And finally, you can use the for function to add up all the values. We could even write this a bit shorter. In Kotlin, there is a function called SumBy, which is basically the same as these two functions. So we could do the same thing we are doing in the map function, and then it's going to add up all the partial values for us. It looks like we're done, but I will add a final test just to make sure that this works for complete games. And finally, I would try to reduce the size of this code by converting this into expression bodies. And we can also get rid of the return types. As we can see, the code looks very concise when using functional programming and pattern matching. Constants can be declared outside classes, so we don't need static constants in a class as we do in Java. Another thing to mention is that in Kotlin, ifs, whens, try-catch, all of these expressions return a value, making the code even more concise. And finally, the IntelliJ plugin adds a good support for Kotlin to make our lives much easier. So this is all. I hope you enjoyed and see you next time.